Hello everyone, welcome to Unlock Maths. Today we have to discuss method of partial fractions for quadratic irreducible factors. Here we are going to consider non-repeated quadratic factors, right? So yes, let's consider this f of x is equals to this fraction p of x by q of x. Yes, we have to consider this is as a proper rational function, right? Now let's consider this q of x is factorized in quadratic factor. So yes, if we have this q of x, if we consider this can be factorized, this is as a x plus a, or we can write this is as a, consider this is bx plus a, and next factor is this px square plus qx plus r, right? So here this is linear factor and this one is quadratic factor. Now this is a irreducible factor, that means this cannot be factorized in linear factor, right? Where this p, q, r, these are the constants. Now yes, this f of x can be written as, then by putting the value of this q of x here, we have this is here, right? So how to resolve this is in partial fraction. Yes, this denominator, this q of x is of degree 3, right? So here we have, this is first linear factor. So for this linear factor we have to take one constant, this is a, and in denominator here we have to write this bx plus a, right? And next here we have, this is quadratic factor, right? So for this here we have to take two constant. So next constant, this is b and c, we have to write in this way, this is bx plus c upon this quadratic factor. This is px square qx plus r, right? So yes, in this way we have to resolve this f of x in partial fraction, right? Next, if we have this q of x, this is as, consider this is, if we have this is as a, this is bx square plus a, this is first quadratic factor, and next quadratic factor if we have, this is px square qx plus r, right? Yes, this is two quadratic factor and these are irreducible factors, right? And again these are a non-repeated factors. So yes, how to decompose this is in partial fraction. Yes, what we have to do, first we have to write down this all function here. Yes, now here we have two quadratic factor and both are non-repeated factor, right? So for this first quadratic factor we have to take two constant. If we take two constant a and b, so here we have to write this is ax plus b upon this factor, right? bx square plus a. Next here another two next constant. If we consider that constant c and d, for this factor here we have to write c and d, this is as a cx plus d for this quadratic factor, right? So this is here px square qx plus r, right? So yes, here we have to take four constants for this two quadratic factors, right? So in this way we have to resolve this fraction f of x in partial fraction, right? Similarly, if we have, yes, if we consider this q of x in three quadratic irreducible factors, that means at that time we have to take six constant, right? And we have to write down in this way, right? So yes, we can say that this procedure can be applied for n number of factors. Only here we have to remember that when we have quadratic factor, we have to take two constant for each quadratic factor, right? So yes, let's understand this procedure by one simple example. So here we have this f of x. Yes, this is proper rational function, right? Where degree of this numerator is less than degree of this denominator, right? Now we can check that here in this denominator here we have two quadratic irreducible factor, right? Now we have to resolve this function in partial fraction. So how to resolve this is here, yes, we have to take two constant for this is, so two constant are here, this is ax plus b for this first factor. Then next factor, this is here we have x square plus 4. Next constant we have to take in this way, right? Cx plus d. Yes, we have resolved this fraction f of x in partial fraction in this manner, where we have to find the values of this constant a, b, c, d, right? Now, yes, we have to proceed for this one. So, yes, what we have to do, we have to take this here, we have to take cross multiplication. So, yes, take this LCM here, multiply this is here, this is x square plus 1, x square plus 4. Now, this is ax plus b, x square plus 4 plus this cx plus d into this factor x square plus 1. And this side, this is as it is. Yes. Now, yes, we have this denominator. Both denominator are equal. That means we can cancel out this is here and we can write. Yes, we have cancelled out this denominator. Right. Now, next here we have to simplify this is. That means we have to do the multiplication of this 2 bracket. So, multiply this is here. Here we have now we will collect the term of x cube, x square and so on here. So, here we have this ax cube, cx cube, then x square, x square. Then here terms of x, right? Then constant terms. Now, yes, we can common out this x cube. So, here we have this is same here. Take x square common. Same here, take this x common. And this constant term, this is here. Now, yes, we have to solve this equation. Yes, here we can collect the term of x cube, x square, x and constant term. So, here for this we have to equate this. So, by equating the terms of this x cube, x square, here we have, yes, coefficient of this x cube, this is a plus c, right? And here we don't have the term of x cube. So, here we have a plus c is equals to 0. Then this b plus d, terms of x square, here we have, so coefficient, this is here 1. Same here, this 4a plus c, no term of x on this side. So, here we have 0. Next 4b plus d, constant term is here 6, right? So, we got this 4 equations having these unknowns a, b, c, d. Now, we have to find value of a, b, c, d, right? Now, yes, we can check that from this one and this one we can find out value of a and c. So, what is here? We have this a plus c is equals to 0, right? And here we have this 4a plus c is equals to 0. So, solving this equation, we get here, yes, c get cancelled. Here we have minus 3 is equals to 0. That means, yes, this gives a is equals to 0. So, from this, yes, if we call this is as a first, second, third and fourth equation, right? So, from 1, right, this is a plus c is equals to 0. By putting the value of c, by putting the value of a here, we get c is equals to 0, right? This is we have 1 and this is here we have taken 3. Similarly, now, yes, we have to find value of b and d. Yes, so for this we have to solve equation this 2 and 4, right? So, here we have this b plus d is equals to 1 and this 4b plus d is equals to 6, right? Yes. So, how to solve this is here by eliminating constant d here. here we have this is minus 3b is equals to minus this 5. So we got this is here b is equals to 5 by 3, right? Now from this equation b plus d is equals to 1, we can find value of d here. So here we have d is equals to, this is 1 minus 5 by 3. So this is here we get minus 2 by 3, right? So we have find the values of a, b, c, d. We got here a and c is equals to 0, b is equals to 5 by 3, and this d is equals to minus 2 by 3. Now we have to put values of this constant in this equation. So here we have this f of x is equals to, yes, this equation by putting this constant, yes, we get here this a is equals to 0. What is the value of b? B is 5 by 3, right? And what is c is here 0 and d minus 2 by 3. And this is, yes. So we got this 5 by 3 x square plus 1 and this minus 2 by 3 x square plus 4. So we have resolved this fraction in partial fraction, right? This here we have resolved this function f of x in partial fractions, right? Now we can check that whether this decomposition in partial fraction is correct or not. So for this what we have to do, we have to do simplification of this one to get this is. So yes, let's proceed here. Yes, when we simplify this side, yes, we got this fraction, this original fraction, right? That means the decomposition of this function in partial fraction is correct, right? So yes, how we have proceed for this is here, yes, when we have this given function, this f of x, we have check here, we have two quadratic irreducible factor, right? So we have taken this 4 constant in this manner, right? And we have solved in this way, right? So here we have to remember that when we have to find the constants a, b, c, d, we have to proceed in this way, right? We have to collect the coefficients from both sides and we have to solve these equations for getting the values of constants, right? So yes, that's it for now. See you in the next video. Thank you. Keep watching.